Okay, so this question says the function of f is given by, there's your equation, and it says estimate the rate of change at x equals 2. Okay, so how do you get a good estimate of a rate of change at a given point, right? We can't. We need some sort of range. Okay, so if you're looking at a graph, which is what this is, like if you're looking at a graph, if I want to find the rate of change between 2 points, I literally can find the slope of the line that connects those 2 points, right? That's basically what we're doing. Yes? Okay, so what happens if you only have a single point? You want to get as close to that as you possibly can, but it still needs to be a line. So it can't be, we're not talking about a tangent line to a single point. We're talking about this is a secant line. But we want to get it as close to the point that we're looking for as possible. So you'll see, like, this guy's going to move it. I don't know how he does it, but it's so smart. I'm going to figure this out, okay? If you actually physically move the point closer, so if I'm trying to find, I can't remember if he's trying to find the rate at A or the rate at B. But he's going to move it. I think it's at B.
Is there an audio?
There is, but he's saying, there. Okay, he's trying to get the rate at A. So he's going to move B as close to A as he can possibly move it. Okay, without making it tangent, where it only intersects once, and not going past it. Okay? And by doing that, you get the most accurate, still not 100%. But it's the most accurate rate of change at a given point. So that idea, that concept is what we will use to find the rate of change at 2. We will literally pick a number that's really, really close to 2. A lot of the times they do 0.001. And you will use those 2 points to find the rate of change. Okay? So if it's at a given point, you're trying to find a number that's very, very close but bigger than, because you want the rate of change from there to before. Very, very close, but not the same number, because obviously you can't just plug that in, and then find your rate of change. So we're going to pick the second coordinate point to be 2.001, and then we're going to literally plug that into the calculator. So I'm going to find f of, can I already move it? I did. I'm going to find f of 2.001, and then I'm going to subtract from it f of 2, and then I'm going to put this over 2.001 minus 2. Yeah.
Why is that one not 1 point? Which questions are on tomorrow's quiz?
So that's a great question. There's a quiz review on your to-do list, okay, that covers the content that's on your quiz. It's not obviously going to cover everything and all the wording and all the things, okay? But it does have 1/6, which was your inverse, so it starts at top was the 1/6. So the question could be, is it 1-to-1 or does it have an inverse? If I'm looking for an equation, what makes it not 1-to-1? What would make an equation not 1-to-1?
Oh, it doesn't pass the horizontal. Or if it's an even power.
X can't be raised to an even power or an absolute value. The graph of that would fail your horizontal line test, but you want to know it from the equation because you don't want to have to graph it. Yeah.
Yeah, so on the homework, 6 and 7 are essentially what we just did.
Correct. Yep.
If it's an x to an even power, but it has a restriction.
Then it could be 1-to-1. Great question. So what if it's an x to the even power, but it has a restriction, and that restriction cuts it? Then it's 1-to-1, right? So you got to pay attention to that kind of stuff. If it is, so you might get a question that says, is it 1-to-1? And then you're gonna get a question that says, find the inverse. And to find the inverse, we switch the x and the y. We solve for the new y, and our very last step is going to be putting the f -1 in there. I will dock points if you don't do that. Yes.
Can you explain what you said about the restriction with the even power?
Yeah. So like if it said, so for example, if it was this one, right? Like this question itself, would this be 1-to-1? No. What if I said where x is greater than or equal to 0? Now it's only this side of my graph, and that is 1-to-1. Yeah.
How would you know that graph?
You would have to understand your transformations enough to graph it.
So you would get like a simple one, you wouldn't get like something, like some absurd shit.
It could be absolute value or it could be squared, because those are the ones that would be restricted, but yeah.
If there was a squared and we found like the minimum, would that like tell you where it like reflects? If it's
Yes,
one?
if it's a parabola, yeah, yeah. Okay, then super easy stuff like identifying independent variables. Remember, independent is what you're plugging in, that's your x. and dependent is your variable. So what's inside is your independent, and what's outside is your dependent variable, okay? So you're going to be identifying which parts are which. Then these guys, the graphs where we're looking for concave up, concave down, increasing, decreasing, your zeros, and your y-intercept, okay? All of that's going to come from a graph. And then came your rate of change. So rate of change by way of, there's 3 different things on this. By way of an equation where you're given the 2x values, so not one where you're just going to get given 1. Then rate of change from a chart, then rate of change from a graph, okay? We got this, people. Yes, okay, yeah.
Are there any questions styled on AP that would be on the quiz?
Honestly, like, this is an AP styled question. This is an AP styled question, yeah. And there are parts that are multiple choice and there are parts that are open-ended. Yeah.
So like rate of change on the graph is slope? Or
Yeah.
Yeah.
Inside's dependent. Yeah, what you're plugging in is independent because you pick whatever you want. But what you get out of it is dependent on what you plug in. So that's dependent. Yeah. All right, so we're good on 1. Yes? Yeah, we understand that we'd have to change that interval, right? Because from 0 to 1 is 1, but from 1 to 4 is 3. And then from 4 to 8 is 4, and then from 8 to 10 is 2. So if I wanted to figure out what those were, this would have been negative 15, this would have been 8, this would have been 12, okay? Biggest change there is D.
Why not negative 15?
Because it says increase the most, okay? If it said change, now you got to take that into consideration, but it says increase, so you want only the positive one, right? It's one little word, right? Changes everything. All right. 2 was the graph of the function, and it says which of the following is the average rate of change? Sorry, the least. Yes.
Why did you do 6 times 2 for the last one?
Because the interval here, right? The change in the x is 2. Here, the change in the x is 4. Here, the change in x is 3.
I still got it right because I still multiplied it and give a greater number, but I didn't know like that.
Yeah, that would have been your over, right? So it would have been the average change over the x2 minus x1 equals the actual change, right? So your average rate of change or your change in the rate is what you're missing, right? The y is what you're missing, but you know the other parts. Yeah. Okay, so then this one says of the following, which interval is the average rate of change the least? Okay, it doesn't say a positive rate of change or a negative rate of change. So when you're going from -3 to -2, it looks like it's almost like we did this yesterday, right? Like we estimated that to be like a 4.5. And then from -1 to 0, -1 to 0, appears to be a difference of like 2.5, -2.5. Then it goes 1 to 2, 1 to 2, and that appears to be like a -1. And then comes 3 to 4, 3 to 4, which is like I don't even know. It's almost like no change. It goes up and comes back down again, right? Okay, so it could be like a 0.2 even, something like that. If we had from here to here, okay? So the least includes that negative sign, right? -2.5 is less than -1, and that's why it's B. Yeah.
Can I ask about
Can you ask about 1? Yeah.
when would you take into consideration that it's negative?
If it said, what's the biggest change? And it didn't say, where does it increase the most? So where does it change the most? I would ignore, if increase was not there, now you're looking at the -15.
So increase means that you're only looking at the positive ones?
Correct.
And what if it said where does it decrease the most?
Then you're only looking at negative ones.
And then where does it change the most?
Then it doesn't matter.
Okay.
Which is what this one is. It's not saying it's a positive rate of change or a negative rate of change. It's literally saying what's the least change. Yeah.
I know what you mean, but wouldn't the 3 to 4 be the least because there's no change? So it would be the
No, because it's not saying the least positive change or the least negative change. So you're literally looking for the smallest number.
okay.
Yeah.
So if something had no change, like something that had a technically a bigger change would be more like.
There's not really no change on that.
Mhm.
There is a positive change. So, I mean, you'd have to get really close to see it, but it's not constant. Constant would be no change. A horizontal line there would be no change, right? But that is actually, there is a little bit of change there. And it's positive, which is going to be bigger than the negative change. Yeah. We're just approximating where it hits the y-axis. So like this point here, from this point to this point is my change. So I'm going from this point to this point. So if you actually wanted to give coordinate points, you give coordinate points, you do the y2 minus y1 over x2 minus x1. Yeah, Rodrigo.
So if it was constant, would that be the lowest change?
No, that would still be 0. So a negative change would still be smaller than 0. Yeah.
I thought negative just meant like that it was decreasing.
The rate of change did, yeah, it did decrease.
I thought it just meant like the line was decreasing.
Remember, that would be that it's like, so if you're thinking decreasing, we're talking rate of change is decreasing. Whereas negative is actually the direct, like increasing, decreasing of your curve. Yeah.
So increasing, positive, decreasing, negative, and then for like lowest or least?
Increasing points, not increasing rate of change.
So
Increasing points is your graph going up. Decreasing points is your graph going down. Increasing rate of change is concave up. Decreasing rate of change is concave down. So the difference is, are we talking about the actual point values, or are we talking about the rate of change of those point values? Those are two different things.
or least rate of change would be the most, like smallest?
The
number?
smallest number.
Okay.
Yep. All right, then came the calculator question. It said the function is given by, and this got cut. Okay, so I graphed, the equation was x squared plus 3x minus 5, and I got this graph here, okay? So the change happens at your minimum point. Your minimum point was negative 1.5 and whatever this is. So negative 1.5 comma whatever that y is, okay? And if you look at that, it has a negative rate of change, which means it has a negative rate of change, and for interval from x is greater than 1.5, and then it has a positive rate of change where x is and then, sorry, I think I just said the words different. Where it's less than 1.5, it's got a negative, and where it's greater than 1.5, it has the positive. Always positive is going to be obviously like a line with a positive slope. That would be something like that.
Wait, going back to the other question, if it said decreases at the greatest rate, would then you look at the decrease and you pick the biggest number?
Decreases at the greatest rate, yes. But it would be the biggest negative number, which is actually the smallest. Like if you're doing negative
Yeah, so
15,
like-
it's smaller than negative 12. Negative
it would
12
be
is the
negative 12.
biggest negative number, yes. All right, then came the month one, and it said, of the following on the first day of which month is the rate of change of the temperature the greatest? How do we do on this one? Good, we found the difference, right? You found the rate of change between, so if it's May, you found the rate of change between May and April, this guy. If it was February, we went from February to January, which would have been that guy, which is negative, right? Then August would have been here to here, and November would have been here to here, which is also negative. So from these, there was only 2 with positive change, and that blue little segment is definitely steeper than my red. Yeah.
And then let's say if it was May and June, and they were pretty similar, would we have to calculate like the?
I would think if it was something that close, it would give you coordinate points.
Okay.
Yeah. Yeah.
The ones with negatives, they like make it less, right? So like.
Correct. Yep. Yeah.
Going back to what she said, if it was said decreasing the most and your options were like negative 12, negative 15, which one would it be?
Decreasing the most is the biggest decrease. The biggest decrease would be actually, so is that what you're saying?
Yes.
So that would be the negative 15. Negative 15 because it has the biggest drop.
But I thought you said greatest is like.
So greatest is overall. If you're doing greatest decrease, I don't think they'd ever put those words together.
Okay.
Because you're only comparing the decreasing and you're still looking, so you're only looking at the negative ones, but you're still looking for the biggest change. So the biggest change is the 15 over the 12. Think about what it would look like, right? Like if you literally had a change from, we're saying this is decreasing, right? And you're saying from here to here is one of them. And then you're saying from here to here is the other one of them. Whichever of those is the bigger number or steeper change, that's the greater change.
Why wasn't it like that for the other graph?
Because it was increasing.
So they would never ask.
No, because it didn't give you an increasing or decreasing. It just said overall.
So why couldn't it be the
It
negative
technically
one?
was the biggest one. If we had absolute valued those, right? No, because it said decrease. Yeah. All right, 5 says a function f has a negative average rate of change on the interval of x from 0 to 10. So if I was to look at something from 0 to 10, what's it mean to have a negative average rate of change? It's concave down, okay? And then it says from 0 to 5, it has a negative average rate of change, right? And then a positive average rate of change from 5 to 10. Which of the following statements must be true about function h if I add those two? So these are two different functions. And this is where you kind of have to do the visual. If I add, and this is where it's so hard because it doesn't say where on my y-axis this is. I could have something that is like this, and I could have something that's all the way down here, okay? Right, they both said negative? No, one says positive. This, okay? Or it could have overlapped. And when I add the two y's in each spot, I might get something that is positive or negative, but at least I know it's going to be bigger than my lowest point. So it is still decreasing because it's still concave down, but it can be increasing, decreasing, or both on that second interval. So if this is up here from 0 to 5, that's going to pull this up, but it still stays decreasing. That's the hardest part. And then for here, we don't know how high it is. So these are ones I would think it might be easier to draw a visual, but realize your visual might not 100% match it, okay? This, again, this kind of wording is not something we're testing on yet. We're going to get here, but this is how confusing some of this is and how one word can change everything. Yeah.
So if it was like, if we thought of it like how it was overlapping, how like from 0 to 10 was negative, and then from 0 to 5 was negative, would it just like where it overlapped?
No matter where you add them, they're still going to be decreasing. Okay. Right. So if you take something that's decreasing and you add it to something that's decreasing, it's going to stay decreasing.
You know that the first half is for sure decreasing.
Correct, because that's what it says. It says from 0 to 5, right?
But the second half.
But the second half, we don't know if it's positive or negative. And that's where you lose that. Yeah.
So like, when is this gonna pop up
On your AP test.
That's it? Not like.
Well, no, before that, we'll start doing some tests that are AP style tests. But not yet. Yeah. Okay. Yeah.
I don't get how it's like increasing because like if you add both of them, like one of them is increasing and then one of them is
So, but you don't know how high that value is. What if your increasing is so high that it pulls your decreasing up?
but like what if it's like the other
That's why you don't know, and that's why it's saying it could be any of those.
but I know but like how do you know it's decreasing from 0 to 5?
Because it says it here. This is decreasing with decreasing, right? Decreasing and decreasing are both down. Then it says this is increasing, and part of that is, and that's still decreasing. So we don't know if our increase is so high that it could pull up the decreasing, or if it's low enough to keep it decreasing. We don't know. What we do know is a decreasing with a decreasing is going to be pulling it down. An increasing with a decreasing, we don't know the rate in which they're increasing. So is it increasing faster than the decreasing? Now it's going to pull it up. But if it's increasing the same, no change, or less, then it's going to stay decreasing. That's why you don't know the difference. Does that make sense?
Yeah.
Okay. Edward.
If they're both decreasing from the point of 0 to 5, why is the second
These were both down. I just drew it rough, but they were both. No, I don't even know what I drew anymore, Edward. I'm sorry. I don't even know what I was saying when I drew those things. They are both decreasing. Decreasing, and then the other one is decreasing and increasing. Yes. Okay, sorry. Decreasing, and then it changes to increasing. Yes. Okay. So I don't even know what I was saying when I drew that. Okay, but does that make sense? From the point where it changes, these are both decreasing. Yes? But then this one is decreasing and this one is increasing. So it should have really turned there. Okay? And that's where you don't know how the rate can affect the other one because we don't know how fast it's increasing or how high that ratio is or how low it is. Okay? We're going to move on though because we got to get to the other stuff. Okay? This to me, honestly, like I fought this question because I was like, we pinpointed every little word in this question. And I still, honestly, I don't know the answer. So maybe if somebody can figure out how this is different from the other ones, why is this looking for the overall change and not a rate of change? The way this answer is worded and found is if you literally add all of these together, you get the same number as you literally add all of these together, having no impact on your interval. Okay? Edward, do you understand this speak?
No, I was gonna ask, where do you just like multiply it by 6 and then add it all together?
It doesn't work.
Like I got 96.
Well, if you multiply by 6, it's the same thing as doing all of it.
I took points and it didn't work.
Same. I did rate of change for each of them and then added them up, did the same thing. The only thing we found, so I actually went to Miss Barrett. I was like, help. And she's like, I think it's worded bad, to be honest. The only thing we found, so we're not even going to worry about it yet. Maybe this will be March's problem. The only thing we found is that when you compare this wording to some of the other ones, it says the average rates of change instead of average rate of change. So it's talking about a cumulative change instead of the overall change, okay? So if you went from -3 to 17 and then you put it over 30, it didn't work. If you added up the 5 different rates of change, it didn't work. The only way this works is if you physically add them all, okay? I'm praying this is not something we have to deal with. And if it is, we'll go over these with a fine-tooth comb in March. Yeah.
Is there like a video on that?
No.